Hello everyone, welcome to lesson 9 in math. It's comparing, adding, and subtracting fractions. And this is going to be part 2 of the fractions unit. In the last lesson we talked about the basics of fractions and just getting to know what fractions are, when we use them, and stuff like that. Today we're going to compare, add, and subtract fractions, and stay tuned for the next video after this where we will be multiplying and dividing fractions. So part 1, comparing fractions. Let's start with a little minds-on activity. So you might think that 3/4 is less than 2/3 because sometimes we get confused. Like, okay, 2/3, if we have a pizza and we make 3 slices, then they're going to be bigger than making four slices. So meaning each slice of that third is bigger in terms of the size compared to each slice of a pizza that is cut in quarters. But the correct answer, despite that unique little philosophy, is that 3/4 is greater than 2/3. And in order to better understand this and memorize it, we shouldn't really be imagining things that are hypothetical. We should not be thinking about it. We have to have a mathematical mindset. So in order to compare fractions, there are two methods. Talking about method 1, you have to divide the numerator by the denominator and then compare. So say we have like the same example, 3/4 versus 2/3. We're going to, for the first one, 3 divided by 4, that's the numerator and denominator, and that is 75 hundredths. And for 2/3, we're going to divide the numerator by the denominator to get 66 hundredths. So now comparing 0.75 and 0.66, we see that 0.75 or 75 hundredths is greater. Therefore, 3/4 is greater than 2/3, and that's how you read that. And then this is another example. I haven't shown my work here, but if we divide 14 by 15 and 10 divided by 11, we are going to get that 14 over 15 is greater. And you can kind of see a pattern here. When you do have like a greater denominator, then it's most likely that that fraction will be greater compared to the other fraction that has a smaller denominator. But always show your work before you do that. Method 2 is finding the LCM, or the lowest or least common multiple, for the denominators and rewriting the fractions and then comparing. So using the same examples here, so you could see that we get the same answer regardless of the method we use. So starting with the multiples, when we're listing the multiples of 4, we get 4, 8, and 12, and that's about it. And then for 3 is 3, 6, 9, and 12. And we talked about multiples in a previous lesson, which I will link here on the screen. And so we see that 12, and the reason that we're stopping for 12, because there's many more multiples for 4, but we're stopping at 12 because 12 is also common in 3, and that's the least common multiple. So we get 12, and therefore whatever we do to the bottom, we have to do to the top. So if we're multiplying the bottom by 12, then we're multiplying the if we're multiplying the bottom by 3 to get 12, then we're multiplying the top by 3 as well, and 3 times 3 is 9. And now for the second fraction we had over here, we're multiplying 3 by 4 to get 12, and we have to do the same thing to the top, so 2 times 4 is 8. And now we can compare 9/12 compared to 8/12. And here we can see that 9/12 is greater than 8/12 by one number from the numerator. So, and if we want to rewrite that using the same fractions we were given, we would say 3/4 is greater than 2/3. So you can see either method works for this comparing fractions part. You just choose whichever one you like better. If you like working with decimals or if you like working with fractions, it's your choice. And I have another example here for method 2, just so we can have our own, just another example here for us. But I haven't shown my work. If you want to do that yourself, you can do that definitely. But 2/3 is greater than 2/5 because the greatest common or the least common multiple here is 15 for 3 and 5. So 3 times 5 is 15. 5 times 3 is 15, and whatever we do to the bottoms, we have to do to the tops. And eventually, after showing our work, we will see that 2/3 is greater than 2/5. And then in this example, you can see that 2/3, 3 is a denominator, which is less than the 5 here. So sometimes that rule doesn't always apply. Here I have some practice questions for you, and you can use any method you want. I will be putting the answers in the description box. Part 2a, adding fractions. So when we're adding fractions, if we have the same denominators, you don't need to add the denominators, you just have to add the numerators. That's because if we do add the denominators, then we're just going to come up with a whole new fraction, and that's not going to solve the question we have. So remember, if it's the same denominators, all you have to do is add the numerators. An example could be like 1/5 plus 1/5. Numerator plus numerator is 2, and we just copy the denominator, which is 5. And that's 5 all throughout. And say we have something like 4/13 plus 6/13. We copy the denominator, but 4 plus 6 is 10. So the final answer is 10/13. But say you have different denominators. Then you have to find the lowest common multiple, just like we talked about right here. And then you have to add. So say if we have this example, 1/5 plus 1/10, well, what's the answer? So you have to list all the multiples of 5 and 10 to get the least common one, or the lowest common one. So in this case, we have 10. That is the least common multiple in 5 and 10. And so we say that in order to get 10, you have to multiply 5 by 2. So whatever you do to the bottom, you do to the top. And in order to get 10 from 10, well, you just multiply by 1. So whatever you do to the bottom, you do to the top. And you get 2/10 plus 1/10. And the answer is, just adding the numerators, 3/10. And as you can see, it's always 10. So here are the practice questions for you. Please reduce if needed. You always want to reduce your answer if possible. So part 2b, subtracting fractions, and just like when you're adding fractions, when subtracting fractions, you don't subtract the denominators, you just subtract the numerators. So say we have this question, 9/10 minus 8/10. Well, since the denominators are the same, 9 minus 8 is 1. So this is our final answer. And if we have 7/8 minus 3/8, the 8 is always copied, and 7 minus 3 is 4. And if you have different denominators, you have to find the lowest common multiple and then subtract. So say you have 7/8 minus 2/3. You have to list all the multiples of 8 and 3 until you get the least common one. So in this case, for 8 it's 8, 16, 24, and for 3 you have to go all the way to 24 so that they can match. 8 times 3 is 24. Whatever you do to the bottom, you do to the top. And 3 times 8 is 24. Whatever you do to the bottom, you do to the top. And so we get a common denominator of 24. 7 times 3 is 21, and 2 times 8 is 16. And 21 minus 16 is 5. So the final answer is 5/24. So I have another example here where we have whole numbers involved and mixed fractions. So when you have this kind of scenario, there are a couple of things you have to do. In order to subtract this, you have to make the 8 into a mixed fraction as well. And in order to do that, you have to subtract the digit by 1. So when I'm saying digit here, I'm referring to the whole number here, which is 8. So you have to subtract it by 1. And then, you have to see what the denominator is on the other fraction to make one whole of it on the digit. And then subtract the fractions. So it might be a little wordy here, but we're going to work through this, and then you'll better understand it. So part 1 is to subtract the digit by 1. So 8 minus 1 is 7. So here it got 7. And now the next thing is to see what the denominator is on the other fraction. So the other fraction here is 2 and 3/4. So the denominator is 4. And now I have to make one whole of it on the digit. When I say one whole, it means 4/4. So say if the number was, I don't know, like 10, it would have been 10/10. If it was 25, it would have been 25/25. That's what that is. When the numerator and the denominator is the exact same thing, so that's one whole. So 7, 4 over 4. And now we have to subtract the fractions. So here I have 7, 4 over 4 minus 2, 3 over 4. So 7 minus 2 is 5. Again, you don't subtract the denominator, so 4 copies 4. And 4 minus 3 is 1. So the final answer is 5 and 1/4. And here are some practice questions for you if you need it. And if you want to stop there, go ahead. This is all the stuff you need to know for today's lesson. But if you do want to give yourself a little bit more of a challenge, then here I have another question that we are actually going to be doing together. Say we have a question like 6 2/7 minus 3 5/7. Well, in this case, the denominators are the same. So we don't have to do any of that lowest common multiple stuff. So 6 minus 3, those are the whole numbers, is 3. And now 2 minus 5 over 7. Well, we can't subtract 5 from 2 unless we're talking about integers. But at this level here, we don't want to use integers. So we don't want anything to be negative, right? So if we take 2 minus 5, it's going to be -3. We don't want negatives here. So what can we do? Well, here we have to take 1 away from the whole number, and then we have to add the denominator to numerator number 1 and subtract the numerators. So again, it's a little wordy here, but I'm going to show you what I mean. So the first one was to take 1 away from the whole number, so that means subtract 1. So 3 minus 1 is 2. So here I have 2. And now the next thing is to add the denominator to the numerator number 1. So that means we have to take 7 and add it to 2. When I say numerator number 1, it's because here at the numerator you have 2 and 5, so there's 2 numerators in this case. We have to add the denominator to the first one. In this case, the first one is 2, so it's going to be 2 plus 7, which is 9. And then I have 9 minus 5 in this case. So 2 and then 9 minus 5 over 7. 9 minus 5 is 4. So the final answer is 2 4/7. So that's what you do when you have something that is going to lead you to a negative fraction. Okay, and an advanced calculation, again, you don't have to do this, but if you feel like you want to give yourself a little bit of a challenge, then you definitely can. And then at the end, I do have some practice questions for you. So advanced calculations to me are when you have multiple fractions to work with in one expression or one equation. So in this case, the question we have to work with is 2/5 plus 3/4 in one bracket, plus another bracket which consists of 8 over 9 minus 2 over 3. So in this case, we have brackets involved, and we haven't talked about BEDMAS yet, but we will soon. But we have brackets involved, meaning we have to work with those first, and then we have adding and subtracting going on. And then the whole like equation is being added. So what we have to do first is talk bracket by bracket. So 2/5 plus 3/4. Now, so pretend this whole part doesn't exist. So over here, what I have to do is make sure the denominators are the same. So the lowest common multiples of 5 and 4, and I find that it is 20. So that means 5 times 4 is 20. Whatever I do to the bottom, I do to the top. And 4 times 5 is 20. Whatever I do to the bottom, I do to the top. So 3 times 5. And then I get 8 over 20 plus 15 over 20. Now, let's talk about this part. So 8 over 9 minus 2 over 3, the denominators have to be the same. And when I write the multiples down for 3 and 9, I see that the lowest common multiple is 9. So 9 is already 9. We just have to multiply by 1 to make it the same or let it be the same. And for 3, I have to multiply the bottom and the top by 3. And then I get 8 over 9 minus 6 over 9. So what we just did is we made the denominators the same. And now we're going to calculate within each bracket. So here it's 8 plus 15, which is 23 over 20, and 8 over 9 minus 6 over 9, which is 2 over 9. And now the next thing we have to do is make the denominators the same here, because pretend if these little bracket signs were not here, it would have just been a regular, like how we've seen over here, it would have just been a regular fraction equation. So now we have to find the lowest common multiple of 20 and 9, and it's 180. So 20 times 9 gives us 180. Whatever we do to the bottom, we have to do to the top. And 9 times 20 gives us 180. Whatever we do to the bottom, we do to the top. We get 247 over 180 as an improper fraction, which we talked about in our last lesson. But as a mixed fraction, it could be 1 and 67 over 180. And we talked about how to get from an improper fraction to a mixed fraction and vice versa in our last lesson. So if you need help with that, you can definitely check that out. So this is our lesson for today, and here are some practice questions. There are many practice questions here for you. I will be putting the answers to all of them in the description box. So thank you so much for watching this video. Be sure to check out any of the previous ones if you do need extra help or references, and stay tuned for future videos. Thank you very much, and see you in the next one.